Okay, in this section we're going to work on solving right triangles and some applications, just a little terminology for that. First of all, when you're solving right triangles or solving any triangle, what you are doing is you're looking for all unknown angles and unknown sides. In this case, for the first example, we're given one angle and one side. So we'll be looking for the other angles and the other two sides. And what I recommend first is for you to do a drawing. So let's draw this right triangle. I got an angle of 21 degrees, so that looks about good. This will be my 21 degrees. And fill in the information that you know about the triangle. So we know that this is 21 degrees down in here. We have a right angle because it is a right triangle. And now start to label it. I said that A was 21 degrees, so we'll call this A. And by standard naming of triangles, their angles and corresponding sides, then that means that the side over here is going to be lowercase a. In a right triangle, the right angle is always C. So the side opposite C, the hypotenuse, should be lowercase c. And that makes this our B, which makes this B, which equals 67.2 centimeters. Okay, so we've drawn the triangle. Now, when we in order to solve, so right over here, solve, we want to have angle A, angle B, angle C, side A, side B, and side C. So some of this information is given. You have to know something about it. We know that angle A is 21 degrees. We know that angle C is 90 degrees. And we're given that side B is 67.2 centimeters. So this makes it clear we are looking for angle B, side A, and side C. So right off the bat, finding angle B, and uppercase letter means that it's representing an angle. If you like, you can put an angle symbol beside it, but it should know that if it's uppercase, it's an angle. Now, since it's a right angled triangle, we have 90 here. Therefore, the other two smaller angles have a sum of 90. So we can find angle B by subtracting from 90. So 90 degrees minus 21 degrees equals 69 degrees. And let's fill in our answers as we go. Okay. In a different color, I'm going to work on one of the other sides we need. So let's do solving for side A, for example. We know that side A is opposite angle A. So we do have an opposite side that we're looking for with respect to an angle that we know. And that now we have to use a given side because we can only have one unknown. This will be our unknown. So and side B is what with respect to angle A? So here's our side B. It is the adjacent to angle A. So we are going to use angle A and side B to find side A. We see that we have opposite and adjacent involved. That means that the ratio will be tan. So tan A is A over B. There's our equation. Now we fill in the two values that we do know, which are this one and this one. And this will be solved for. Okay? All right, let's work on that. So, tan 21 equals A over 67.2. Solving for A, Since A is divided by 67.2, multiply on both sides by 67.2, which gives me that A equals 67.2 tan 21 degrees. A is equal to 25.8. Alright, going back over to my area where I'm keep track of my answers, 25.8 centimeters. Great. Let's now solve for side C. Have a look at the triangle. Side C is the hypotenuse. So it's going to, and we already know now the other shorter side. So we could use the Pythagorean theorem. Also, we can use trigonometry. I'm going to go with the trigonometry route because that's something that you're practicing more a little right now. So I'd like to do it with the trigonometry route. Plus, I recommend that when you're solving, you use the given values rather than values that you have calculated. If we use Pythagorean theorem, we calculated side A. If anything had gone wrong there, we'll be wrong in our C also. So sticking with, if possible, using the values that you were given, that's best. It's not always possible. So if we look at, we've got angle A. We know its adjacent side. We would like to find the hypotenuse, which trig ratio involves adjacent and hypotenuse, and maybe you're getting used to them now. So yeah, side C is hypotenuse, side B is adjacent to A, adjacent and hypotenuse is cosine. So cos A equals B over C. Subbing in the numbers, cos of 21 degrees equals 67.2 over C. Alright, when the unknown is in the denominator, this is a two-step rearrangement. So I would like to multiply both sides by C. This is going to get a little messy down here. So C multiplied by cos 21 degrees equals, and if I multiply this side by C, I'm eliminating C from down here, so that equals 67.2. Now I would like to just solve for C, so divide both sides by cos 21 degrees. Like this. Cos 21 over here, cos 21. That will cross those out. C equals 67.2 divided by cos 21, which is, if I'm going one decimal place, 72.0. And let's put that in our list of answers. Now, you can also check this by Pythagorean theorem using the two shorter sides, the 25.8 and the 67.2, and it will work out. I've checked it also. Okay, here's a double check on your triangle now to see if it makes sense. In all triangles, the largest angle should be opposite the longest side. The second largest angle should be opposite the second longest side, and the smallest angle should be opposite the shortest side. And that works out. This triangle makes sense. These answers seem to look good. We'll try another with different unknowns. Alright, here's another example now. Solve the right triangle given side A is 24.2 centimeters and side C is 45.6 centimeters. So we're given two sides, we don't know any angles. We will have to solve for both of the angles that are unknown and the other side. So let's have a look. We're going to draw out another triangle. I recommend, again, draw your triangle. So here, let's draw a triangle again. We don't know what the angle sizes are, so it's a little bit tough to decide. So it really won't matter in the diagram. We could fix it later once we know more. But we do know this is a right triangle. So let's start to do some labeling. We've got a right triangle. This would be C. This would be lowercase c. So therefore, we do know this side at 45.6. Now we can just decide which is A and B. It really doesn't matter. So this angle could be A. This could be B. It could be the other way around. I'm going to call this one A. If that's the case, then this side opposite it is side A, so this is 24.2. That makes this B and side B. Alright, so just to keep track of what we will be solving for again, we're going to have A, B, C, and side A, side B, side C. We were given side A at 24.2 centimeters and side C at 45.6 centimeters. And we know this is a 90 because we were told it was a right triangle. Great, so from that we can see we have two angles to solve for and a side to solve for. If you want, you can go ahead and find the third side using Pythagorean theorem. Okay, so Pythag theorem, we'll find the third side. B is equal to the square root of c squared minus a squared. Subbing that in, we will get the square root of 45.6 squared minus 24.2 squared. And B turns out to be 38.6. Let me keep track of that in my answers. Okay, so now we can sort of tell a little bit about this triangle. We've got the hypotenuse, the longest side. B is opposite the second largest angle because it's the second longest side. So from this we can see that angle B should be larger than angle A. And that's just a little double check of things that should make sense, and we should be seeing that happening in this triangle as we go and solve. Alright, now we need trig to solve the rest, get some angles. So we could solve for A or B first. It really doesn't matter. I'm going to go and solve for angle A first. And so with respect to A, to angle A, we know, here's our angle A. With respect to angle A, we know opposite side and we know hypotenuse, okay? Those are given. We know opposite and hypotenuse. This helps us to decide which trig ratio to use, which one involves opposite and hypotenuse. And if you're beginning to get them memorized, you will know that it is sine. So sine A is opposite over hypotenuse. And so now we can write an equation filling in the numbers. We have A is our unknown. These two sides are known. Sine A equals 24.2 over 45.6. If I figure out what this is now as a decimal, sine A is equal to 0.5307. Okay, this is why we learned how to solve for an unknown angle given a trig ratio. The correct way to rearrange this equation to solve for A is to say sine inverse of that value, 0.5307. So you grab your calculator, second function sine, make sure it's in degrees. A is equal to, let's call that 32 degrees. All right. Next, we want to find angle B. We could use trig, but now that we know two angles, and we know that A and B add up to 90, then B should be equal to 90 degrees minus 32 degrees, which is 58 degrees. Double check that we have the smallest to largest and, actually the smallest opposite the shortest side, the medium angle opposite the medium length side, and the 90 degree opposite the longest side. And that makes sense. Okay, a couple more things when it comes to the applications, alright? Applications. Really, I just want to make sure that you know a couple of terminologies so that you can interpret information given to you in an application question. Angle of elevation. The angle of elevation, otherwise known as inclination. And basically, this type of an angle is measured from a horizontal, so generally the ground, but from a horizontal, looking up. Okay, so in the book they described this the worm's eye view. There's a little worm on the ground. What would his angle of elevation be looking up at something? So maybe you're measuring from the ground up to the top of the tip of a tree. You'd measure an angle of elevation. The other one is the angle of depression. That is measured from a horizontal, so parallel to the ground, looking down. All right. And so this is called the bird's eye view. Okay, you're the bird up here, and the other one you are the worm. So you're measuring from the horizontal, looking down. So maybe you're up at the top of a building, measuring the angle of depression down to the base of another building or something. And that's just two bits of terminology that I want you to know for the application section. But other than that, with the information given, always draw the triangle, fill in the known values, determine what your unknown values will be, and begin to work with either Pythagorean theorem or trig to solve. Once you have solved, make sure your answers make sense using the smallest, medium, and largest angle relationship to their corresponding sides. Okay, thank you.